let's go into transistor. So transistor is another component, okay, in electronics that is a sambungan from diode. Okay, so there are a couple of words that we need to be very familiar with when we talk about transistor. We need to remember again what is the meaning of the depletion region. We need to know what is the meaning of the junction voltage. Ini semua saya sudah jelaskan and I have taken such a long time to discuss what these two means. Kenapa wujudnya depletion region? Kenapa perlunya ada junction voltage? Okay, and how it functions, okay, is that the electrons can only go and fill the holes if you give them enough voltage, enough energy to overcome the junction voltage. Okay, and then of course, the two most famous words in diode is forward bias, okay, and reverse bias. So all this come into play when we talk about this alat called the transistor. Okay, so transistor is very commonly known. You can see transistors in microprocessors such as this. It's a very, very, very amazing piece of technology that has literally changed our world today. Without transistors, you would not even be able to, to access Google Meet. So yes, blame the transistor. Blame the transistor for PDPR. Okay, but you can also blame the transistor for the existence of your handphone. You can blame the transistor for the existence of Genshin Impact. You can definitely blame the transistor for WhatsApp. Okay, it is because the transistor exists. It is because of the technology of the transistor that you are able to watch this video live and you're able to watch this video on YouTube. You can WhatsApp with your friends and you can pour out your heart to whoever it is that you love, or you can, stalk your crush, or okay, or you can have bias towards whichever BTS member that you are currently biasing with. It is because of the transistor that all this is possible. Okay, so if you're asking me again, sir, why do we even learn physics? Okay, we learn physics in order to get, so that you can fall in love with Jimin or whoever it is that is your bias now, like you. Okay, so let's talk about the transistor. What is the function and the use of a transistor as a current amplifier? This is the main purpose. Okay, so a transistor is an electronic component that has three terminals. Okay, you will always see three legs, okay, 1, 2, 3 over here, okay, which are called the emitter, the base, and the collector. Emitter is pemancar, base is tapak, okay, dan collector is pengumpul dalam bahasa Melayu. Okay, emitter is pemancar. Tapi we always call this with the three leg names, E, B, and C. E for emitter, B for base, C for collector. The main functions of the transistor are two. Number one, it serves as an amplifier, and number two, and even more important for us today, it serves as an automatic switch. Okay, the two main functions that you need to know, okay, is that transistor amplifies the current. Secondly, it also serves as an automatic switch. So if you take a look, I know this is in Malay, but we're just going to continue anyway. So the system amplifier boleh menguatkan suara penyanyi. Okay, it can, have you ever asked how does an amplifier work? Okay, there are tons of transistors in there. Okay, an amplifier system or system pembesar mengandungi microphone, amplifier, which is a transistor, and a pembesar suara. Okay, the street lights. Okay, the street lights, or if you live in an apartment complex, you will notice that at certain times or at certain weather, tiba-tiba lampu itu akan bernyala sendiri. Okay, who do you think yang pergi menyalakan itu lampu? It's not the security guard yang pergi tekan all the switches. No. Okay, even the lampu jalan, dia akan menyala pada waktu malam dan padam pada waktu siang. Who does this? Okay, it's not a ghost that goes around or Harry Potter yang ada itu, the lighter that can take out all the lights and put back all the lights. No. Okay, all this is controlled by an automatic switch. Okay, that uses a kind of resistor which we call a light dependent resistor and combined with a transistor. And all these things we are going to look at in this subtopic. Okay, sorry, the repeat. Okay, so let's first of all get to know our transistor. Mari kita mengenali transistor dengan lebih dekat. Kerana bila orang tak kenal maka tak cinta. Tapi lepas kenal makin membenci. Kan bilang orang begitu? So, structure of an Npn transistor. Now, Npn, if you remember from diodes, okay, there are two types of diodes. Okay, which is the N type and the P type. And a semiconductor diode is a diode that is a combination of both one N type and one P type. That's why there's only two legs. But in a transistor, because it has three legs, okay, there are two possible combinations that we can come up with. Number one is the Npn transistor, which looks like this. The collector is an N semiconductor diode. Sorry. Sorry. The collector is an N semiconductor. The E is also an N semiconductor, but the base is connected to a P semiconductor. Okay, so this is how the structure will be like. So three semiconductors kita kasih gabungkan untuk menjadi satu diode, untuk menjadi satu transistor. Okay, and the symbol for the Npn transistor is drawn like this. Okay, now if you're confused about how to draw this, we always start with the circle. Okay, and then we draw the base first. Okay, and then satu huruf T lah. Okay, satu huruf T, and then this is the base. Okay, then lepas itu, from here, okay, you just draw out and like this. So this will be the C, and then over here and here, this will be huruf E. But we always start with the circle. Okay, we always start with the circle, baru kau melukis base, baru kau lukis yang dua kaki yang lain. Now, this is the most important thing in the Npn transistor. The arrow must always point towards the emitter. Okay, it is the thing yang membezakan antara Npn transistor and the Pnp transistor. Look at the difference of the arrow in the Pnp transistor. Okay, the Pnp transistor is an arrow going inwards from the emitter to the base. Okay, so the symbol, the arrow, the direction of the arrow tells us what kind of transistor it is. Okay, Npn or Pnp. So Pnp is, the base is, it's quite easy to remember Pnp lah kan, because you know, P for collector, N for base, and P for emitter. But the most common transistor, and the one that we are going to heavily talk about in this subtopic, is the Npn transistor. Kita lebih berminat dengan ini. There are uses for Pnp transistor, okay, tapi itu bukan kita punya scope perbincangan di sini lah. Okay, if you want to do this, you have to learn higher level electronics engineering, not low level physics. Okay, but as a starting point, if we understand how the Npn works, the Pnp is pretty much the same. Okay, all right, so the arrow in the symbol shows the direction from current B to E, that is for the Npn. Manakala Pnp, it shows from the direction of the current E to B. Now, let's talk about the three terminals and the functions. So the first terminal is the emitter terminal here. Okay, in the Npn transistor, the arrow points towards the emitter terminal. And the function of this terminal is to emit. Okay, dia yang memancarkan. Okay, it's going to emit the charge carriers. The base terminal, okay, is to control the charge carriers. Okay, whether it is Pnp or Npn, it's pretty much the same. Okay, the base terminal controls the charge carriers, and the collector terminal, okay, what it does is it collects. Okay, it collects the charge carriers. Ya, jangan juga kamu, okay, kalau emitter adalah emits charge carriers, collector adalah collect charge carrier, maka base adalah base the charge carriers. No, okay, malangnya tidak. The base is to control the charge carriers. Dia macam, you know, like army camp base lah. Di situlah semua charge carriers ada. Okay, dan dia yang mengawal, okay, kamu lah sikit-sikit keluar macam tu. Okay, so the base, like base camp. Okay, so what does the arrow on the emitter in the symbol of the transistor indicate? It indicates the direction of the current. Okay, in an Npn transistor, the current always flows towards the E. In the Pnp, it flows from the E. Okay, the three terminals and the direction of the arrow tells us exactly this. All right, moving on. Now, let's talk about the basic circuit for the Npn transistor. Sebelum kita meneruskan ini, I want to warn you that there is a very long explanation to this. And if you don't understand what is going on, if you want me to repeat it again, Okay, this is the time to ask me to do it. Okay, because transistor is just like the AC generator. Okay, once you see it, you cannot unsee it. But in order to see it, it will take some time. Okay, let's take a slow look at this. Now, in a basic NPN transistor circuit, okay, we usually connect, okay, two batteries. Okay, so this is what we call the base circuit. Okay, and this is what we call the collector circuit. Okay, litar tapak, litar pengumpul. Okay, litar tapak, litar pengumpul. There is a function for the resistance over here. Okay, and there is a battery here and another battery in the collector circuit. And they're all joined together by this transistor. Now, name the two current paths through the transistor. It is the base circuit and the collector circuit. Okay, we need to understand this first. Okay, so the base circuit and the collector circuit. So the type of current, three types of current would be the base current, which flows in the base circuit, the collector current, which flows in the collector circuit, and the emitter current, which is a temporary combination of the base and the collector current. Okay, think about it. Flows here, comes here, flows here, joins here. And then once it comes to this junction, it goes back to its own place. Okay? So far so good, Okay. So base current, collector current, and emitter current. And the emitter current, as I said, is a temporary combination of both the base and the collector currents. So therefore, the comparison of the three currents, now this is a fakta, okay, ini adalah fakta. Get this right, the biggest one is obviously the emitter current. So dia adalah gabungan kedua-dua. But this is the first thing that we need to understand, is that in any transistor circuit, the collector current is always bigger than the base current. But, kejap, I will come to the but later. But remember this first. The collector current is always bigger than the base current. And we're not talking about, base current is 10 amps and the IC current is 11 amps. It's not that kind of difference, We're talking about base current is usually microampere, darab 10 kuasa negatif 6, and emitter current is usually about milliampere, which is darab 10 kuasa negatif 3. It is 1,000 times difference. Okay, 3 zeros difference. Okay, it is that much of a difference. So technically, you shouldn't even be writing like this. No, you should be writing IC is way bigger than IB. Okay, because one is in microampere and the other one is in milliampere. It's 1,000 times different. Okay, but okay, kejap, we will come to this in a little while. Okay, because it's like, kenapa perlu ada this current that is so tiny sedangkan ada current yang begini besar? Kan? Okay, we will come to that in a little while. Now, what is the function of the resistance R1 and R2 in the above circuit? Okay, the function of the resistor in the base circuit is to limit the base current. Okay, dia adalah menjadi penghad kepada the base current. Now, R2 is actually an output. Okay, so in this case, dia letak satu resistor, but it can also be a bulb, okay, a lampu mentol di mana dia akan menyala, atau a motor yang akan menyebabkan pergerakan berlaku. Okay, or it can also be a speaker. Okay, di sini kita letak kita punya speaker. Okay, so you can add another note here, it can also be a speaker. Apa-apa peranti lah. Okay, anything that you need to use a transistor for, that's where you put the R2. So dia tak semestinya satu resistor. Okay, it can also be, any peranti lah. Speaker, bulb, motor, things that require the IC to flow through it. Okay, so even in the transistor circuit, the function of the resistor is different. Okay, now hold on to these two facts. Number one, the resistor got different purpose, and number two, this one, that IC is way bigger than IB. And you're talking about 1,000 times bigger. Okay, sebab satu adalah milli and satu adalah micro. Next page. Okay, the two junctions in the transistor. Remember that when we were looking at diodes, I said that when the N semiconductor and the P semiconductor, okay, when they combine together, you are going to get a depletion region. Remember this? Okay, here's the N, here's the P. You are going to get a depletion region over here. Okay, and kenapa the depletion region wujud is kerana, you know, elektron melompat dan meninggalkan tempat kosong di belakang, okay, yang sangat sedih, and you left my heart and whatever lah. Okay, so that's the depletion region. Now, the depletion region, okay, hanya boleh dikecilkan if there is a voltage that is big enough for the electrons to cross over. Okay, right now, all the electrons over here cannot cross over because of this depletion region. Okay, dia macam satu gaung yang sangat luas lah. Okay, so you know, and the electrons like, saya tak kuasa lah nak crossing over. Okay, so what happens is, if you want the electrons to cross over, you have to give enough voltage to the electrons so that they can close the depletion region. Okay, diorang boleh mendekatkan the depletion region, and then the electrons can cross over. Okay, so that's what we studied when we were doing semiconductor diodes. I don't know how much of it you remember lah. Okay, but when this statement comes, there are two PN junctions in the transistor. We're talking about this junction and this junction. Because now we're combining three semiconductor diodes. Sorry, three semiconductors. Okay, three semiconductors, therefore two PN regions. Okay, so let's call this the BC junction. As in, you know, the junction between B and C lah. Okay. And the second one will be the BE junction. Okay, and so the BE junction or the base emitter junction is forward bias. Lihat. Okay, look at this. This is positive. B is positive. This is N. This is N. And so the positive is connected to the P and the negative is connected to the N. So this is forward bias. But if you look at it the other way, in the collector circuit, this is reverse bias, because the N is connected to the positive and the P is connected to the negative. I know, we ignore this lah. Okay, we just ignore this. Okay, so it's reverse bias. So the BC junction is reverse bias. Okay, this is reverse bias because the N and the P is here. So this is reverse bias to this, and this one are forward bias to this, because this is the N connected to the negative, and then the positive is over here. Okay. So, in the in the BE junction, okay, this one is forward bias. So the P type, okay, the P type. Hold on. Let me just see this. Oh yeah, I'm right. Okay, so in the BE junction, it is forward bias. So the P type over here will be positive terminal, kena sambung pergi positive, and the N type will be sambung kepada negative. Okay, so it's also forward bias here and forward bias here. PN, yeah, PN. Okay, so in both the circuits, the BE junction is forward bias, but in the BC junction, okay, the collector circuit is reverse bias. All right, so let's take a look at this. The terminal here is positive and negative, so that's why it is reverse bias. Sini adalah negative, okay, sini adalah positive, so it's reverse bias. Okay, now we will usually call the base circuit as the input and the collector circuit as the output. Okay, so when we have R1, R2 over here, so the R1 over here is a resistor to limit the base current. We saw this just now. And the R2 is the output lah, whatever that you want to put here. Want to put a speaker, want to put a motor, want to put a light bulb. Okay, we see kita lihat kejadiannya, okay, in this R2. Tapi untuk tujuan perbincangan kita, we just leave it as a resistor for the time being. Okay, now, so all this we've seen already. IE is more than this one, but the total of IE is equals to IC plus IB. Now, this is where the thing starts. When IB is 0, okay, IC is also equals to 0. This is fakta number 1. Okay, when there is no base current, there will be no collector current. Okay, why? In a little while I will explain. Okay, kita ambil dulu fakta ini. When there is no base current flowing, there will be no collector current. That's why kita cakap ini sebagai input dan ini sebagai output. Yang menyebabkan output untuk terjadi adalah sekiranya ada input. If there is a base current, then there will be a collector current. Okay, and the second fact that we need to know is that the IB controls the IC ya, bukan saja dari segi on dan off, tetapi juga if there is a small base current, it will produce a very big collector current. Okay, remember just now I said that the base current is in microamps and the collector current is in milliamps. Something so small, okay, is able to make such a big change, is able to amplify, is able to amplify, the current that is already there. Okay, a very small base current will give you a very big, okay, collector current. Now, guys, when I say very big current, I'm not talking about like, wow, 1,000 amps, it's still milliamps. To us, it's very small, but it is big enough on an electronics level. Remember, electronics is all molecules, and these are not human level, Okay, all molecules, electrons, holes, all very tiny, tiny. Okay, milliamps is good enough to get them to work. Okay, now here's where the notes come in. So we said just now that the BE junction, okay, is forward bias. And so if it is forward bias, okay, the BC junction is reverse bias. So when the switch S is open, when this is open, what is happening is that the BC junction will remain reverse bias. That's why there is no current flow in the collector circuit. Okay, there is no current flow over here. Okay, so the BC junction remains reverse bias. Okay, and now this is where things start to get interesting. When I turn on the switch, okay, bila saya pasang ini, the electrons from the BE junction will cross over to fill in the holes in the base. Okay, electron dari sini akan melompat pergi sini, and then they move to the positive terminal of the battery. Sini dan sini, because it's attracted to this positive terminal of the battery. Now, most of the electrons from the emitter will be attracted to the collector because, number one, the base is so thin, dia sangat nipis. Okay, that tidak cukup lubang untuk elektron mengisi. There is not enough holes for the electrons to mengisi. So what are the electrons going to do? They're going to cross over to the other side dengan harapan mencari lagi lubang kosong. Okay, namun hampa. Because tiada lubang di sini. Sini semua elektron. Okay, and so because of that, all these extra electrons yang tidak mengisi lohong di sini, they are going to give a much bigger, voltage. Okay, so the collector voltage is very much bigger than the base voltage. Okay, so the majority of the electrons are pulled towards the collector. This voltage biasanya lebih besar. Okay, look at the batteries, 3 batteries. Here is only 1 battery. Okay, so cukup untuk menarik elektron pergi sini, tetapi ini sangat jauh lebih besar. It's going to bring it all across. Okay, all across. So hanya sedikit saja yang masuk sini dan okay, marilah kita enjoy di sini. Tetapi selebihnya akan pergi ke sini. So ini dia punya tarikan sangat besar. And that's why I said that the IC is way bigger than the IP. But all this can only happen, when there is a base current. Remember the first statement I said just now. If there is no base current, nothing happens here. Because this is reverse bias. Okay? N bersambung kepada positif. P bersambung kepada negatif. This part is reverse bias, so tak boleh jalan. We studied before, reverse bias, current doesn't flow. But when we provide a current in here, when we turn on the switch, we are giving the electrons over here power to grow across here and also to come here. Okay, and because we give them the power to go across here, this one can start to function because dia boleh menarik sudah. Okay, there's going to be a lot of electrons here that is going to be tertarik kepada the positive junction over here. Okay, so let's talk about the Pnp transistor. Okay, Pnp transistor works along the same way. Okay, but the BC is reverse bias. Okay, the BE is forward bias. Okay, pretty much the same lah. I'm just going to, sorry, let me just give the full drawing so it's easier. Okay. Oh, sorry. Okay, so this is the full drawing. Okay, so, but in this case, take a look at this. The batteries are diterbalikkan because the position of this one is terbalik. Take a look at the NPN. This is the NPN. NPN, the positive is up here, negative is down here, positive up here, negative down here, NPN. But if it is PNP, we change the direction of the batteries. Okay, we change the direction of the batteries. Okay, so that, but the working principle is still the same. There must be a base current flowing in order for a collector current to be produced. Okay, that is basically the basic function of the transistor. Okay, dia hanya boleh hidup, transistor hanya boleh hidup sekiranya ada arus tapak. Tiada arus tapak, ini transistor tidak dapat berfungsi. Why? Because it is reverse bias. The BC junction is reverse bias. Tidak boleh berfungsi. Okay, it is reverse bias. But when we give it enough energy over here, it's going to let the electrons cross over. Okay, so when it can cross over, dia akan, this ini yang ini depletion region ni akan menjadi lebih kecil. Okay, sebab dia mampu ditarik sudah oleh this battery. Okay, all right. Sorry, I don't know. Every time I come to this subtopic kan, memang it's a lot of explanation lah. Okay, it's a lot of explanation. Takes a while to get it. Okay, but I hope that your experience in electromagnetism has taught you that if you give yourself some time, you work through it slowly, you will see it. Okay, you will see it as I have seen it. Okay, it takes a while. All right, so let's talk about practical. Let's talk about practical terms. Okay, observe the brightness of the bulbs when the switch is open. What does this indicate about the base current and the collector current? Okay, look at this. Switch is open, switch is open, switch is open. Okay, we find that bulb M1, the lights are off. We don't see anything about the lights being on. Okay, and the bulb M2 is also lights off. Okay, and the reason for this is because the circuit is not complete. Okay, in this one, L1, the circuit is not complete. Okay, and therefore we can conclude that there is no base current flowing here. Very logical lah kan? Kalau katakan, okay, if you take your finger or your hand and you close this part of the circuit, you just talk about this part only. Very logical, right? If the switch is open, the circuit is not complete, and so there's no base current. Okay, very logical. Okay, but in the collector circuit here, okay, in the collector circuit, why is it that the lights are off? Is because the transistor is not turned on. Okay, tiada arus mengalir di sini, so the transistor is turned off. And so because of that, we say that the collector current is equals to 0. Okay, so the first fact that I have mentioned since the beginning is that if there is no base current, there is no collector current. Okay, IC depends, really depends, okay, on IB. Betul-betul. Okay, kalau collector current ada, mesti IB ada, mesti base current ada. It's impossible to have base current tiada, tapi collector current ada. No such thing. Okay, at least not at our level. All right, let's talk about when the switch is turned on. Okay, now I turn on the switch. Okay, what's going to happen is that M1 is going to be very dim. Okay, indicating, and M2 is going to be very bright. Okay, this one, L2 is going to be very bright. Indicates that RB has a very high resistance. And therefore, IB is very small. Okay, manakala in M2, the collector current is large compared with IB. That's why L2 is much brighter, okay, compared to L1. Okay, so a lot of facts. One of the other facts that you need to know is that RB, okay, the resistance in the base circuit, they are the high resistance. Okay, because high resistance, current is small. We've learned this in the past lah. Okay, so number 3, what is the requirement for the transistor to be switched on? The transistor can only be switched on if there is a small base current that can produce a minimum voltage, minimum BE junction voltage, so that you can turn on the collector circuit. All right. Remember that when I was showing this diagram to you, mana ni? Sorry, where's the diagram? Oh, ni nak. Oh no, not this. This one. Okay. There must be enough voltage for these electrons to cross over. Okay, because sini banyak voltage di sini, but the problem is you know, it is pincang songsang, it is reverse bias. There's a lot of voltage here. Dia mampu menarik, tetapi dia pincang songsang. Okay, the depletion relay is so wide. Okay, so there must be enough voltage for these electrons to cross over, and then this positive terminal is going to bring these electrons even more. Okay, even more to this side. Okay, so that this depletion region menjadi sangat kecil. Okay, kalau ini adalah off, remember all these electrons over here akan tertarik pergi menjauhi daripada sini sebab dia reverse bias. And so the depletion layer here, if you can see, is very, very big. Okay, it's very big. So we need those electrons, we need the electrons daripada sini untuk masuk ke dalam the base in the P semiconductor, so that this guy, the positive terminal, can do his job and pull the electrons even more. Dan menjadikan this, saya conteng sampai kau tidak nampak sudah kan, okay, menjadikan this region lebih nipis. That's the only way that this works. So, kalau ini tidak on, electrons tidak boleh pergi sini. Dan kalau electrons tidak boleh pergi sini, dia tidak boleh ditarik pergi sini oleh positif ini. Okay, dan kalau dia tidak boleh kena tarik oleh ini, this depletion region cannot become smaller and no collector current will flow. Okay, I'm saying this for, I think I have said this like 10 times already, okay, but we need to understand this. Okay, we need to understand how this works. Okay, because again, the transistor is such an amazing technology. You really need to know how it works. Okay, but if selepas 10 kali saya cakap pun kamu masih lagi blur-blur, okay, just remember this, that the collector current, okay, is large compared to IB. Okay, and secondly, the small base current, you just need a little bit of a base current, okay, to produce a minimum voltage BE to turn on the collector circuit. That is the requirement for the transistor to be switched on. A base voltage must exceed the junction voltage, which is about 0.7 volts. Okay, depending on the bahan yang kamu pakai, I think silicon is a little bit lower than germanium. But you know, generally junction voltage, okay, macam yang saya tunjukkan di sini. Sorry, which one here? Here. Okay. So this is the junction voltage. Dia mesti ada cukup tenaga untuk melepasi gaung ini. And minimum requirement is 0.7 volts. Saya pernah dengar satu guru dia cakap ini macam apa tahu, ini macam tol. If you don't have enough money, you cannot pass. Okay, you can think of it that way lah if you want lah. Okay, this junction voltage macam tol lah. Okay, kalau kau tidak cukup duit, kau tidak boleh limpas. Okay, so where do you get the money from? Kau pinjam daripada this kau pinjam daripada this voltage. Okay, this junction, sorry, the base voltage. Okay, supaya the electrons boleh limpas. Okay lah, fine lah. Up to you how you want to do this lah. Okay, but that's the basic requirement. You must exceed a minimum junction voltage of 0.7 volts in order for the transistor to be switched on. And once again, when you compare the base current and the collector current, the base current is not just bigger, it's way bigger, okay, than the base current. Okay, much way bigger. In a transistor, the base current switches on the collector current. Okay, the most important thing that we need to understand at this first part of this subtopic is this, that the transistor can only turn on okay, if there is a base current, and the base current will turn on, the kewujudan base current itu akan menyebabkan transistor switch on, yang akan menyebabkan the collector current to flow. Okay, so that's why there are two functions of a transistor. If there is no base current, there is no collector current. So the base current switches on the collector current. That's why we call this a automatic switch. Okay, because when you turn on the base current, automatically transistor turns on and the base current switches on. Okay. Secondly, the base current controls the collector current. If you change the base current a little bit, it's going to result in a very big change in the collector current. Remember the difference between the collector current and the base current. Base current is microamps, you know. Okay, the collector current is milliamps. Okay, bagi kita kan microamp dan milliamp macam sangatlah kecil, betul kan? Again, at the electron level, bayangkan diri kamu sebagai elektron. Micro dan milli mempunyai 1000 kali perbezaan. Okay, it's just like for us lah. Okay, gram and kilogram is 1000 difference, you know. It's 1000 times of a difference. Pada level of the electron, it is the same thing. Okay, so you change the current a little bit, okay, you will result in a very big IC large. So a small change in IC will produce a big change in, a small change in IB will produce a big change in the IC. That's why we call this an amplifier. Sebab kamu membekalkan arus yang sangat kecil, okay, untuk menghasilkan arus yang sangat besar. How many of you bila kamu nyanyi karaoke, bahkan kamu punya volume suara adalah sama dengan volume speaker kamu. Tolong, maybe Melanie sajalah yang cukup besar suara dia untuk sama dengan speaker lah. But most of you kan, kamu cakap, hello, begitu kan, terus the amplifier amplifies the sound. The word amplifier, okay, the word amplifier tells you what it is. Pembesar suara. Okay, dan pembesar suara ini hanya mungkin, it is only possible because of the transistor. It is working as a pembesar arus. Okay, the transistor functions not just as an automatic switch, but also as a current amplifier. Okay, fungsi transistor, okay, yang paling utama is as a current amplifier. So let's talk about this. Finally, we come to this explanation. A transistor functions as a current amplifier by allowing a small base current to control a large collector current. Okay, the base current is very small, usually in microamps, when you compare with the collector current, which is usually in milliamps. Okay, and you can count the amplification. Okay, this is the formula for the amplification. Okay, the amplification is the collector current divided by the base current. Okay, and as I said lah, it's usually ribuan kali lah, because difference is mega and micro. Milli and micro. Okay, now this last one is the most important thing lah. If you have forgotten everything that I've said, remember this: a small change in the base current will cause a large change in the collector current. Okay, and yeah, it's quite amazing that kamu ubah sedikit bahkan. Okay, terus perubahan yang kamu nampak di collector current adalah sangat besar. Okay. Kalau saya mau bawa ini kepada satu to a moral lesson, it will be this lah. Mau juga moral kan? Yeah. Anyway, I'm almost done with the class today lah. I don't want to continue to the next one because the next one is pretty big. Okay, but let me finish with this lah. This last statement is always very interesting to me. A small change in the base current will cause a large change in the collector current. One of the smallest parts of our body is the tongue. Kita punya lidah lah. Okay, kita punya kotak suara. Okay, it's one of the smallest parts in the body. Let's not go to which is the smallest organ in the body. Okay, let's not talk about that. But one of the smallest parts in our body is the tongue. But do you know that the tongue is so powerful that when you say something, it has such a big effect on everybody else. If you say the wrong things, okay, if you say the wrong things, okay, it will cause a big change in the person. How many of you, because of what somebody has said to you, your life has been changed because of it. Now, somebody said something very hurtful to you, okay, and it caused that person's tongue, okay, basically that person's tongue, okay, caused a very big effect on you, okay. Or how many of you, because of what somebody has said to you, has your life changed for the better, because of what that person said to you. Sometimes we don't think about what we say we just like say what we want to say, but we never think about the effect it has on other people. The tongue is a very small instrument in our body, but it is able to bring about a positive change, or it is able to bring about such destruction, because of the wrong words said. So because of that, and so wow, moral story lah. Okay, but because of that, okay, because of that, it's very important for us lah. Just like the transistor, a small change in the base current creates, like what Mordecai says, a big snowball effect. It causes a big change in the collector current. Suara kamu yang kecil mampu dibesarkan karena kamu yang bekalkan suara tersebut. What you say, okay, whether you realize it or not, has an effect on other people. Will have an effect on other people, especially if you're saying it to them. So the question you should be asking yourself is everything that is coming out of my mouth helpful or destroying other people? Okay, and I'm going to end with this thought for you all today. Okay, sorry, I always forget this, but I need to share this. Okay, sorry, another moral lesson now. Okay, sorry, I don't know if you've seen the quote of the week. Okay, I found this quote to be so interesting. Okay, I don't know if you can see this, but it says FOMO. FOMO is fear of missing out. So fear of missing out creates suffering. Okay, yet those who suffer, yet those who suffer have the fear of missing out. Interesting. Right? Fear of missing out now creates suffering. We are always scared that we are missing out on something in life. Kan kita takut kita ketinggalan. And that sometimes is very suffering. And I see it, I mean, sometimes when you all talk, I see that happen lah. Kamu takut ketinggalan, so you try to catch up, but that makes you suffer. But I want you to think about it in the other way. Okay? The fact that you're suffering now, okay? The fact that you're suffering now is because you want something better in your life. Okay, you are afraid that you will miss out on something in life. Hopefully lah. Okay, I'm not sure whether this. Saya tidak tahu kalau ini apa ini semua, because you're supposed to teach us physics, not about life. Okay, but it's true. People who suffer, okay, people who are willing to work hard, okay, and people who are willing to suffer, to go through all this kepenatan that you guys are going through right now, there has to be a reason for this. Okay, you are afraid of missing out on something that life has to offer for you in the future. And so I want to encourage you, don't give up. Okay, I know it's tough. I know that among all the students in our school, well, at least as far as I know, okay, among all the students in the school, your class has kind of a very heavy burden. Bersusah sudah dahulu, bersenang-senang kemudian is a very simple way of saying this. But yeah, we don't think about it now, but it is true. Okay, bersusah-susah dahulu, bersenang-senang kemudian. Saya boleh cakap ya lah, okay lah, boleh lah, benar juga lah. There are some people yang bersusah-susah dahulu dan selepas kemudian pun masih tetap bersusah-susah. Okay, but that doesn't mean that you should stop working. Okay, that doesn't mean that you should give up. Okay, there is somehow in all this uncertainty, I'm sure there is a purpose, okay, to why your SPM kena tunda sampai bulan March. I'm rolling my eyes to the heavens and back, okay, for this. I'm sure there is a reason to this lah. Okay, I'm sure there's a reason for all this suffering, and I hope that what is motivating you is not that you're fearing of what you're missing out now, but you're fearing of what you're missing out in the future. Okay, don't let your future tergadai ya, kerana kamu tidak sanggup untuk bersusah payah sekarang. Okay, and with that, I'm going to end our Thursday class. So moral betul. Okay, there's no homework today. Okay, there's no homework today because I already said your tutorial from yesterday's class is the homework for this week. But I want to tell you that we are going to finish this next week, including the tutorials, and we will finish this chapter for good. Okay, besar mungkin saya tidak akan buat kelas tambahan semasa cuti. I may give you some exercises to do if you want. I may give you some sample trial papers to do if you want to do. Okay, and then we can do private discussions. Atau kalau kamu mau panggil saya untuk, sir, can we have a discussion on this paper? We can set a date. Tapi kamu yang tetapkan. Okay, you set a date. Let's say if you're the only one lah, kamu mau, saya mau one-on-one session lah with some, maka kepala otak kamu lah, tiada lah. Okay, not one-on-one lah. Okay, kalau kamu rasa kamu mau buat, if any one of you feel that you want to have an extra class, kita set masa untuk membincangkan kertas soalan tersebut. Okay, but otherwise I won't call for one because I think you will probably need time to study on your own as well. Okay, all right everyone, have a good weekend. I'll see you all next week. Take care.